All right, so let's talk about how to count the number of neutrons in an atom. The question is how many neutrons. And just to keep it simple, all we're going to do is subtract two numbers to get the neutrons. So I tried to keep the numbers small so that you don't need a calculator. And again, as we get to the next videos, all we're going to do is subtract two numbers to determine how many neutrons are in a given atom. So if you find this video confusing, the explanation, just go ahead and skip it because you don't need to know all this information in order to subtract two numbers to get the right answer. And maybe just point out this is a topic that had confused chemists for quite a long time when they discovered that different atoms had different numbers of neutrons. So again, I'll give a little background here, but you don't need to know all this information in order to do the problem. All you really need to do is subtract two numbers. So notice we got four tables here, right? Scientists love to report data in tables because it's simple, it's explanatory, it's visually appealing, right? A lot of people get tables when they see them. And the alternative to four tables would be writing out four paragraphs for essay questions describing the number of neutrons. So again, you're welcome to write essays if you like, but I think it's a lot simpler just to put a few numbers in each table. So as we look at this first table, we've got hydrogen -1, we say hydrogen 1, hydrogen 2, and hydrogen 3. So not all hydrogen is created equal. It turns out there's at least three different flavors of hydrogen, you might think of them. Just, like there's different flavors of vanilla ice cream. It's all vanilla ice cream, but there's vanilla bean, there's French vanilla, there's plain vanilla with natural flavoring, artificial flavoring, right? It's all vanilla, but not all vanilla ice cream is the same. And that analogy carries out for all the elements. So all the elements have different flavors. Like for example, hydrogen, we're looking at hydrogen 1, hydrogen 2, and hydrogen 3. And these are what are called isotopes. For carbon, we have carbon 12, carbon 13, carbon 14. These represent three isotopes of carbon. Oxygen 16, oxygen 17, oxygen 18. Again, three isotopes of oxygen. And there doesn't necessarily have to be three. For example, nitrogen, we have nitrogen 14, nitrogen 15. We're looking at two isotopes of nitrogen. So what does this number mean in hydrogen 1, hydrogen 2, hydrogen 3? That number 1, 2, or 3 is what's called the mass number. So hydrogen 1 has a mass or a weight of 1, hydrogen 2 has a weight of 2, and hydrogen 3 has a weight of 3. So all hydrogen is going to have the same number of protons. If you look at the periodic table, we see hydrogen element 1 corresponds to 1 proton. So all flavors of hydrogen is going to have 1 proton. The difference between these flavors, or isotopes if you will, is the number of neutrons. You may remember that protons and neutrons each weigh 1. So this mass number is the sum of the protons and neutrons. So to do the math, you're going to take this number after the element, the 1 in hydrogen 1, we'll subtract off the number of protons to get the number of neutrons. So again, take the number that's given, subtract the number of protons from the periodic table, and you'll end up with the number of neutrons. So I'll just point out that this number of neutrons is not given in the periodic table. We have what's called a mass number in the periodic table. For hydrogen, it happens to be 1.008. So some hydrogen weighs 1, some hydrogen weighs 2, some hydrogen weighs 3. This mass number in the periodic table is an average weight of hydrogen. It's a little bit more complicated of a math problem, and we're not going to do that. we are just going to calculate the number of neutrons by subtracting two numbers. And just note again that this number of neutrons, it's not given in the periodic table.